Hey everyone. So in this video, I'm going to continue talking about adding and subtracting radical expressions, and I'm going to demonstrate for you using a couple of examples here how we plan to do that. So this first example here, we see that it's 5 radical 3 minus 3 radical 3 plus 4 radical 8. Well, the two radical 3's are going to go together, but the radical 8 is not matching with the 3. So let's simplify the 8 and see if we can get it to be a 3, right? So we're looking for the factor pair of 8 that has a perfect square. So this 4 on the outside is going to stay the same. The radical is going to stay the same, but what's inside of the radical is going to change. I'm now going to make this 4 times 2, because 4 times 2 is still 8. So this will be 4 times, well, the square root of 4 times the square root of 2, so 4 times 2 radical 2. So 4 times 2 is 8, so this is now 8 radical 2. And unfortunately for us, that did not actually get us the 3 that we wanted, but that's okay, because we could always just put them next to each other. So 5 minus 3, here, 5 radical 3 minus 3 radical 3, is going to be 2 radical 3. So this is going to be 2 radical 3. And so our new expression will be 2 radical 3 plus 8 radical 2, and that's all we have to do, actually. There's no way to combine those because the 3 and the 2 are different numbers under the radical, so that's it. That's our answer, as weird as that seems. So let's look at number 2. 11 radical 28 plus 1 radical 7 plus 2 radical 7. Well, I can see right away that these are going to combine, and this is going to be 3 radical 7. That's really nice. But the one on the left side is not a radical 7, so maybe I could make it. Maybe I can't. Maybe it's like number 1 where I can't, but I'm going to try to make it like a radical 7. So the 11 on the outside stays the same. The radical symbol stays the same. But instead of 28, I'm going to write 4 times 7, which is equal to 28, but 4 is a perfect square. So I'm going to say 11 times the square root of 4 times the square root of 7. The square root of 4 is 2, so this would be 11 times 2 radical 7. So now I'm going to have 22 radical 7. And that's really nice because I wanted it to be a radical 7. So this would be 22 radical 7 plus 3 radical 7, which will give me as my answer 25 radical 7. Cool. So we see that in the first example, number 1, I got an answer that could not be combined. But in the second example, number 2, I got an answer that can be combined. So let's try 3 and 4, and then I think that's where we're going to leave it. So let's look at number 3. 24 radical 5 minus 9 radical 5. Well, this is a nice gift of a question. This one's really straightforward for us. Radical 5 and radical 5 match. So all we have to do is 24 minus 9, which is 15, and then the radical 5 stays. So 15 radical 5. That's all we have to do. Let's look at number 4. Negative 3 radical 11 minus 2 radical 44 minus 5 radical 10. All right, so each of these radicals are different. Maybe I can make them similar, maybe I can't. So I look at 11, and 11's already prime, so I'm going to leave that alone. Negative 3 radical 11. I can't change 11. 44 is not prime, though, and if I look for a perfect square factor of 44, I actually get 4 times 11, and that's great because I need an 11 to match with this 11. So I can simplify that further. But I'm going to hold off on simplifying because I want to look at 5 radical 10. Now 10 I could break up into 2 times 5, but neither of those are perfect squares, so I'm actually not going to do anything with the 10 either. I'm just going to leave it there. So let's rewrite this again. So negative 3 radical 11, that did not change, minus 2 times the square root of 4 times the square root of 11, so this would be 2 times the square root of 11, minus 5 radical 10. So now, if I simplify this one step further, negative 3 radical 11 minus 4 radical 11 minus 5 radical 10, I can combine these two, but I cannot combine this one. So negative 3 minus 4 is negative 7 radical 11 minus 5 radical 10, and that is our finished answer. Okay? I changed my mind. Let's actually do 5 and 6 while we're here. So let's look at 5. The square root of 18 plus 8 radical 27 minus 7 radical 3. So 18, 27, 3, they're all different. 18 has a perfect square factor of 9, so I immediately think this is 9 times 2. Then this, the 8, radical 27, I'm going to rewrite that as 8 radical 9 times 3. And then this radical 3 I cannot simplify, so it stays. Now the square root of 9 times the square root of 2 is really 3 radical 2. And this will be 3 radical 3. And this stays the same. So I can rewrite this as 3 radical 2 plus 24 radical 3, because I multiplied 8 times 3, minus 7 radical 3. Now again, I see that these radical 3's combine, but this radical 2 does not. So it's going to be 3 radical 2 plus 24 minus 7, which is 17 radical 3. All right, let's do number 6, and that's our last one. So we see negative 2 radical 20 plus 2 radical 45 minus radical 5. So we look at 20, we think of the perfect square factor of 20, that would be 4 times 5. And then we see 45, well, what's a perfect square factor of 45? That would be 9 times 5. And then the radical 5 we cannot change because 5 is a prime number. So now I look and I see, well, the square root of 4 times the square root of 5 plus 2 times the square root of 9 times the square root of 5 minus the square root of 5. Okay, so this will be negative 2 times 2 square root of 5 plus 2 times 3 square root of 5 minus square root of 5. All right, so I keep simplifying. Negative 2 times 2 is negative 4 radical 5. 2 times 3 is 6 radical 5 minus radical 5. Now the nice thing about this is that they all have a radical 5. So negative 4 plus 6 is 2 radical 5, and 2 minus 1 would be 1 radical 5. So those are the 6 examples that I think exemplify how this process works. I hope that as you take these notes down, this made a little more sense to you. We are going to talk about this more tomorrow. Have a great night.